Just continuing our look at three-phase supplies. The three-phase system in the UK consists of three phases which from the power station are generated at 25 kV. They immediately leave the power station and they will be transformed up onto the supergrid, which is 275 or 400 kV, and they're then transported around the countryside at an appropriate voltage and dropped down in voltage as we get closer to towns. So once we get into towns, we have to think about the domestic supply, and that's where this next section will take us. If we just concentrate for a moment on what we need 230 volts in a domestic premises, and we also need it in any block of offices, block of flats, light industry, to run things that are important, like a kettle. Before 2005, the colours we had were red, yellow and blue, and each phase is 120 degrees apart. That's how it's generated from the generator. And the EU came up with the idea to harmonise everything, that is to make all of the supplies the same voltage, the same frequency and the same colour of cables throughout the European Union. And with that we got harmonisation, and that resulted in these colours, the brown, black and the grey. So you may go into a building such as Chelmsford College, for example, and you will find in an old cupboard you will find red, yellow and blue, and in a new cupboard you will find brown, black and grey. So you'll find a mixture of the old and the new. If I just move this up a little bit, okay. So the three phases are 120 degrees apart. And you can see that here is the brown phase, here is the black, and here is the grey. And these rise 120 degrees apart. So here is the brown, so that's rising there. 120 degrees later, the black is rising. 120 degrees later again, the grey is rising. So each phase is 120 degrees apart. And between any two phases at any point in time, you will measure 400 volts. That's a nominal value. Just as we say in a domestic property it's 230 volts, the truth is you'll measure a slight variation of that. I doubt that you will ever land exactly on that figure, and it's usually very slightly higher for very complicated reasons. So why do we bother with a three-phase supply? Well, number one, it's extremely easy to generate, but it produces particular advantages which are very useful for us. The end user, that's you and me, in particular in factories and light industry, this is useful, but the end user gets two voltages, 230 volts and 400 volts. The next bit is, because of the way that the three-phase supply is generated, we can use that to our advantage when we connect it to a three-phase induction motor. It automatically produces a rotating magnetic field. And believe me, that is a great advantage to us. And we'll see that when we cover motors. And the final one is the number of conductors in transmission. That is, the conductors which pass over the pylons, over the countryside. We only have three. We have the three phases. We don't have a neutral on the system that travels over the countryside. We assume the system is balanced. That means we have the same current passing through the brown, black and grey phases. And if we have the same current on each phase, then there will be no neutral current. We'll go into that a little bit later, but that is an important fact. And if we can keep the system balanced, so there is roughly the same current on each phase, then we have no neutral current and there's no need for a neutral conductor in the transmission system. Okay, so I've alluded to that there in that note. So let's move on to star and delta, which is some of the most important stuff that we're going to cover in your entire course.